When it comes to fingerprint evidence, not all prints are created equal. Fingerprints are typically classified into three main types: patent prints, latent prints, and plastic prints, each with its own significance in solving crimes. Patent fingerprints are the ones you can see with the naked eye. These prints occur when a person's finger comes into contact with a substance like blood, ink, or grease, leaving a visible impression on a surface. Because they're easily spotted, patent prints can be quickly collected and analyzed, making them an obvious starting point for investigators. On the other hand, latent fingerprints are the invisible clues that require a bit more skill to uncover. These prints are left behind by the natural oils and sweat on our skin when we touch a surface. Although they aren't immediately visible, latent prints can be revealed through techniques like dusting with fingerprint powder, using chemical reagents, or applying specialized lighting. Despite being hidden, latent prints often hold the most crucial evidence in a case, offering investigators the chance to discover and analyze prints that a perpetrator might not even know they left behind. Plastic prints are three-dimensional impressions left on soft surfaces such as wax, clay, soap, or wet paint. These prints retain the ridge patterns of the finger and can be easily photographed or cast for analysis. They are visible without enhancement techniques. Today, we're diving into the fascinating world of fingerprint ridge patterns, exploring how these tiny, unique designs on our fingertips can lead investigators to the truth. You've probably noticed the tiny, crisscrossing lines that make up your fingerprints. These lines are called ridges, and the patterns they form, known as fingerprint patterns, are completely unique to you. But why are these patterns so significant? Fingerprint patterns are created by the friction ridge skin, which is the specialized skin found on the fingers, palms, and soles of the feet. This skin is different from the rest of your body because it's designed to help us grip objects. The ridges on this skin create patterns that are not only unique but remain unchanged throughout your life. Even identical twins, who share the same DNA, have different fingerprint patterns. Alright, before we dive into the details, let's talk about what exactly the pattern area is. Imagine this: on your fingertip, there's a zone where all the action happens. The ridges curve, split, and form patterns. This is the pattern area, and it's key to how fingerprints are classified into loops, whorls, or arches. The pattern area is the part of the fingerprint where the core and deltas are found. These features are key for identifying fingerprint patterns. While loops and whorls have a clear pattern area, most arches don't. The core is the center of the fingerprint pattern, and the delta is the point where a ridge splits or two ridges diverge. Loops have one delta, while whorls have two. These features are critical for fingerprint classification. Type lines are the ridges that frame the pattern area. They start parallel but then split apart, forming the boundaries that enclose the core and delta in loops and whorls. Now, these fingerprint patterns can be broadly categorized into three basic types: loops, whorls, and arches. Let's break them down. Loops, the most common type, found in 60 to 65% of fingerprints. Loops are characterized by ridges that enter from one side of the finger, curve around, and exit from the same side. Loops are further divided into radial loops, which slope towards the thumb, and ulnar loops, which slope towards the little finger. Whorls, found in 30 to 35% of fingerprints. Whorls are circular or spiral patterns that have at least two deltas, the triangular regions where ridge lines diverge. Whorls can be plain, central pocket, double loop, or accidental, each with its own unique structure. Arches, the rarest type, found in only about 5% of fingerprints. Arches are characterized by ridges that run continuously from one side of the finger to the other, without looping back. There are two types of arches: plain arches, which are simple wave-like patterns, and tented arches, which have a sharp rise in the center. While the overall pattern of a fingerprint is crucial, the real magic happens in the details, specifically, in the ridge characteristics or minutiae. These minutiae are the tiny, unique points within the ridge pattern that make each fingerprint truly one of a kind. Let's take a closer look at some of the most important ridge characteristics. Ridge ending. This is where a ridge abruptly ends, creating a sharp stopping point. These endings are critical in fingerprint analysis because they are easy to identify and compare across prints. Bifurcation. Imagine a single ridge splitting into two, forming a Y shape. This is known as a bifurcation. It's one of the most common minutiae and plays a key role in distinguishing one print from another. Trifurcation. Similar to bifurcation, but here, the ridge splits into three smaller ridges. While less common than bifurcations, trifurcations add another layer of uniqueness to a fingerprint. Island. This refers to a small, isolated ridge that stands alone within the pattern, looking like a tiny dot. The presence and position of islands are often used to differentiate prints. Enclosure. Lake. An enclosure, or lake, occurs when a ridge bifurcates and then rejoins, creating an enclosed area. These enclosures can vary in size and are relatively rare, making them significant in forensic analysis. Hook. Spur. This characteristic occurs when a small, curved ridge branches off from a longer ridge, creating a hook-like shape. Hooks are another unique feature that forensic experts look for when comparing fingerprints. Here are other types of ridge characteristics. These ridge characteristics are like the fine details in a masterpiece, turning an ordinary fingerprint into a unique work of art. By analyzing these minutiae, forensic experts can match a fingerprint to its owner with remarkable accuracy. In a forensic investigation, even a partial fingerprint can be enough to identify a suspect. By comparing the ridge characteristics in the print to known records, forensic scientists can establish a match. This process is so precise that it's often used as conclusive evidence in courtrooms around the world. As we've seen, the tiny ridges on your fingers are more than just lines, they're a powerful tool for identification. Whether it's the overall pattern or the minute details within those ridges, your fingerprints are a unique map of who you are, created long before you were born and lasting until long after you're gone. In forensic science, fingerprints provide a reliable and powerful method for identifying individuals, helping to solve crimes and ensure justice is served.